Hello again, YouTube, and welcome back to the video tutorials on RPG from scratch. This is part 9, I believe. First things first, I wanted to give credit where credit was due and reference the XNA 4.0 game development by example by Kurt Jagers, is I believe how you pronounce his name. I'm not positive on that. I just firmly believe in giving credit where credit was due, and the book is great, and it's actually what I'm using as an instructional guide for creating this RPG, and the map level editor as well. In the last tutorial I left you, we created the map cell content class, and we've gone through all this, so I won't bore you guys with that all again. Today what we're going to do is focus on getting the camera for the game all set up. So what we're going to do is we're going to start by adding a new class to the Tile Engine project, and we're going to name that camera.cs. And that brings up this new blank class, and this is a beautiful thing here. And what we're going to do is add our using directives to the top first and foremost. And all we need is the framework for this class. And we're going to set our classes. We're going to do a little something different here. We're going to set the class to public static. And what that does is basically makes it so that all the member functions and all the variables must be static in our class. And this also makes it so that you cannot instantiate a camera object. This is basically like having I guess a method inside your program. It's outside your program if you can follow that. So the first thing we're going to do is, just like we've done before, we're going to add a region, and we're going to call this region data members, data members, and we're going to go ahead and end the region. And we're going to fill this out, and there's surprisingly few variables. I'm just going to go ahead and type the variables we need, and I'll go ahead and describe them in detail after we're done typing all this in. Alright. Again, it's private static. And one little typo there is what we have, so that's no big deal. Alright, so actually this is all the data members of the class that we will actually need, believe it or not. What we have is these vector2s. All this is the intip pops up. It says it defines a vector with two components, and all it really is a way. It's two integers. It's basically the same thing as an array of size 2. But it's really a structure, and what you get is position. You name the structure position. You name the vector2, I'm sorry, position, and we initialized it to 0. And all it is it gives us position.x and position.y, and the position.x contains an integer value. I'm sorry, it's a float value, and the position.y contains another float value. And what this does is it initializes both the x and the y to 0, obviously vector2.0. And we did the same thing for the viewport size. You can the position xy it corresponds to the location in the game, the x and y coordinates in a Cartesian coordinate system. The viewport size is a little bit different, but all that represents is the size of the viewport in the direction of x, which would be its width. So viewport size.x would be the viewport's width, and viewport size.y would be the viewport's height. And the last member variable that we declared here is a world rectangle, and that's basically a bounding rectangle that'll represent the outside edges of the world map itself. And you define the new rectangle. If you hover over the rectangle, Microsoft Visual Studio will give you an idea of what variables it takes, and it takes an integer and x, an integer y, and a width and a height. So this just basically sets a rectangle to 0 in the very upper left hand corner of your screen. And that's pretty much all you need for data members. What we'll get into next is we'll do a new region, and we'll call this region setters, and we will end the region, and we'll fill this out next. The setters, well, let me give you an example. It's easier to give an example. The class will be public, it's static, and void. It returns nothing, and we're going to call this set position. It's going to take a vector2 as an argument, and we're going to call that argument camera location. And so that was pretty straightforward. We created a new setter, and obviously it's prefixed by set, and we're setting the position of the camera. So in actuality, when you call this method, you call camera.setPosition, so it makes sense, and you don't have to add the set cam position, because then you'd be calling camera.setCameraPosition. That wouldn't make any sense. But you feed it a vector2 location, which is again just a point on the screen, an XY coordinate, and we call that camera location. And this is a simple setter method. All this does is actually, this is a little bit more complicated. I forgot to we're going to clamp this to the world rectangle. So what we're going to do here is we're going to say position equals new vector2, and this vector2 is going to be Alright, so let me break this down. We have not yet written this method, but all this is going to do is return an integer value for the width of the viewport, which, as we determined, is just the viewport size dot x. And what this is, the mathhelper.clamp. The math helper is actually an assembly in the Microsoft framework, and that gives you a whole bunch of common math functions. Really easy. And what we did was we're going to call position. We know that position is of type vector, or I'm sorry, of type vector2. So we're going to call position, and we're going to call a new vector2, which instantiates a new vector2 object. And the constructor for the vector2 object takes a float of the x and the float and the y. Like I said, the vector, or it'll be position.x and position.y. And basically what we do here is we use mathhelper.clamp to clamp in the value of x. What this does is, you can see if you hover over it, you take the float value, which we're passing in from the method here, camera location. That's the float value, and then we make sure that it's within a minimum and a maximum amount, and that's all this does. So we want it to not exceed the X direction for the world rectangle, and nor do we want the camera, the actual camera, to go off screen. So we take the world rectangle dot width and we subtract that from the viewport dot width, which will give us the offset. Because remember, in X and A, all images, let's say the image is a square that's represented by this guy right here, it references in the upper left. So by subtracting the world rectangle dot width from the viewport width, we ensure that it references this side here, will never go off the screen. I'm actually out of time, folks. Let me go ahead and I can complete this. We'll do the math helper clamp I actually did a bug there. This needs to be world rectangle dot height, and that does it for that method there. And this actually needs one more, I believe, there. And again, next tutorial we'll go ahead and set some more of these up. But I'm actually out of time, folks. So catch me in the next tutorial. Thanks for